Here, we have a line of code which has an open contact, a positive edge detection, and a coil. We can write a similar line with an address positive edge detector. Let's add a new network and double-click this instruction. We need to enter the address of the instruction of which we want to detect the edge or transition. We'll enter I05 here to detect the edge of this input. For this input, we need to assign it a memory bit address of M01 and insert a coil and assign it the address of Q41. Let's look at how this instruction works. As the CPU executes the program in the first cycle, the state of I05 is checked by the positive edge detector and saved to the memory bit address of M01. In the next cycle, again, the positive edge detector checks the state of I05 and compares it to the previous state saved in the memory bit. If a transition from false to true has been detected, the instruction passes the signal to the output. Just as previous lessons about edge detections have stated, this output will remain true only through one program scan cycle. The address negative edge works in the same manner, except the instruction expects a transition from true to false before passing the signal to the output for only one scan cycle. These two instructions sound similar to the previous two we learned. The difference is that the previous instructions, the positive and negative edge detectors, determine the edge detection based on the result of the logic preceding it. The address detectors determine the edge detection based on the change of state of the address that they're assigned to. Let's create an example and add some inputs here and assign I01 and I02 to them. Let's copy and paste these contacts here in the second network. In the first network, the positive edge detector looks at the result of the logic prior to the detector here, but in the second network, address positive edge detector is only looking at the state of I05 for detecting the positive edge and disregards the rest of the logic. So the address detector only solves its instruction based on the address assigned to it. Now we've learned the functionality of these instructions and how they differ. In the next lesson, we're going to put them to practical use. Let's take a look at the next lesson.